Imagine a material, born from the marriage of quantum mechanics and fractal geometry. This is the realm of quantum fractal alloys, meticulously designed, atom by atom, properties that defy conventional wisdom. A paradigm shift in how we think about materials. Unique structures bending the rules of physics, paving the way for technologies once confined to science fiction, from revolutionizing energy to life-saving medical devices. Quantum fractal alloys are defined by a symphony of remarkable properties. Each property contributes to their immense potential. They represent a giant leap forward. Their thermal behavior is striking. They conduct heat with exceptional efficiency and resist high temperatures, ideal for critical heat management. Imagine engines running cooler and electronics dissipating heat effortlessly. They also exhibit unique quantum phenomena, opening possibilities in quantum computing and high-speed electronics. Heat, a constant challenge in countless technological applications. From smartphones to spacecraft, managing heat effectively is crucial for optimal performance and longevity. Quantum fractal alloys emerge as heroes in this domain, showcasing an unprecedented ability to conduct and withstand extreme temperatures. Their secret lies in their unique fractal structure. This intricate architecture allows heat to dissipate quickly and efficiently, preventing damaging hotspots from forming. Imagine a computer processor that remains cool even under the most demanding tasks, or a jet engine that can withstand the searing heat of hypersonic flight. This is the promise of quantum fractal alloys in the realm of thermal management. But their capabilities extend beyond mere conduction. These alloys exhibit remarkable thermal stability, maintaining their structural integrity even at temperatures that would melt conventional materials. This opens up a world of possibilities for applications in extreme environments, from deep space exploration to next-generation nuclear reactors. The quantum realm, a strange and counterintuitive world, holds immense potential for technological advancement. Quantum fractal alloys, with their unique ability to manipulate electrons at the quantum level, provide a key to unlock this potential. Their intricate structure creates a playground for electrons, where quantum effects like superposition and entanglement become more pronounced. This opens up exciting possibilities in the field of quantum computing, where these effects can be harnessed to perform calculations that are impossible for even the most powerful classical computers. But the implications extend far beyond computation. Quantum fractal alloys could revolutionize communication by enabling the development of ultra-secure quantum communication networks. Imagine a world where information can be transmitted instantaneously and with absolute security, immune to hacking and eavesdropping. Light efficiency, a brighter future. Light, the very essence of our vision, also holds the key to a plethora of technological applications. From lasers to solar panels, the efficient manipulation of light is crucial for advancements in various fields. Quantum fractal alloys, with their unique interaction with light, promise to revolutionize these technologies. Their intricate structure allows them to absorb and emit light with incredible efficiency, surpassing traditional materials by leaps and bounds. Imagine solar panels that can capture a significantly higher percentage of sunlight, leading to a dramatic increase in energy production. But their potential goes beyond energy harvesting. Quantum fractal alloys could pave the way for the development of more efficient and powerful lasers, with applications ranging from telecommunications to medical imaging. Their ability to manipulate light at the nanoscale opens up a world of possibilities for creating new and innovative optoelectronic devices. Mechanical prowess, strength and complexity. Strength and durability are paramount in countless engineering applications, from bridges to airplanes to microelectronics. Quantum fractal alloys, despite their intricate and seemingly delicate structure, exhibit remarkable mechanical properties, defying expectations. The secret lies in the fractal nature of their architecture. This repeating pattern, spanning from the nanoscale to the macroscale, creates a network of interconnected strengthening elements. This unique structure allows them to withstand stress and strain far more effectively than conventional materials, offering a unique combination of strength and lightweight properties. Imagine building materials that are lighter yet stronger than ever before, leading to more fuel-efficient vehicles, more resilient infrastructure, and even more durable consumer electronics. Quantum fractal alloys hold the potential to revolutionize the very way we design and build our world. Eco-friendly in nature, sustainability at its core. As we strive for technological advancement, the environmental impact of our creations remains a pressing concern. Quantum fractal alloys, with their unique properties, offer a beacon of hope in this regard, showcasing the potential for sustainable material science. Their synthesis, unlike traditional alloys, can be achieved with significantly reduced energy consumption and waste generation. This eco-friendly production process aligns with the growing demand for sustainable manufacturing practices, minimizing the environmental footprint of these revolutionary materials. Furthermore, their exceptional durability and longevity translate to a longer lifespan for products, reducing the need for frequent replacements and minimizing waste generation in the long run. This inherent sustainability makes them ideal candidates for a future where technological progress goes hand in hand with environmental responsibility. Transforming industry's real-world applications. The remarkable properties of quantum fractal alloys are not confined to theoretical possibilities. These materials are poised to revolutionize countless industries, ushering in a new era of technological advancement. In electronics, quantum fractal alloys promise to revolutionize device performance. Their exceptional thermal conductivity can lead to more powerful and efficient processors. Imagine smartphones that remain cool during gaming, or laptops handling demanding tasks. In aerospace, their lightweight yet strong nature can lead to more fuel-efficient aircraft. Renewable energy, powering a sustainable tomorrow. As the world transitions towards a more sustainable future, the demand for clean and renewable energy sources continues to grow. Quantum fractal alloys, with their unique properties, hold the key to unlocking the full potential of renewable energy technologies. Imagine solar panels that can harness a significantly larger portion of the solar spectrum, converting sunlight into electricity with unprecedented efficiency. Quantum fractal alloys can make this a reality, paving the way for highly efficient and cost-effective solar energy generation. Their applications extend beyond solar power. Their exceptional thermal conductivity makes them ideal for use in thermoelectric generators, which can convert waste heat into electricity. This opens up exciting possibilities for capturing and utilizing waste heat from various sources, further enhancing energy efficiency and reducing our reliance on fossil fuels. Future frontiers, quantum computing, and beyond. The journey into the realm of quantum fractal alloys is just beginning, and the future holds even more exciting possibilities. These materials have the potential to revolutionize not just existing industries, but also to pave the way for entirely new fields of technology. One of the most promising avenues of exploration lies in the field of quantum computing. Quantum fractal alloys, with their unique ability to manipulate electrons at the quantum level, could provide the building blocks for powerful and scalable quantum computers. These computers would possess computational power far exceeding anything possible with classical computers, revolutionizing fields like medicine, materials science, and artificial intelligence. But the potential applications extend far beyond computation. Quantum fractal alloys could revolutionize medical treatments by enabling the development of highly targeted drug delivery systems. Imagine microscopic robots made from these alloys, navigating through the bloodstream to deliver medication directly to diseased cells, minimizing side effects and maximizing treatment efficacy. Shaping tomorrow, the impact of quantum fractal alloys. The discovery of quantum fractal alloys marks a pivotal moment in the history of materials science, akin to the discovery of plastics or semiconductors. These materials have the potential to reshape our technological landscape, ushering in an era of unprecedented innovation and advancement across countless industries. Their impact will be felt far and wide, touching upon every aspect of our lives. From more efficient energy generation and storage to faster and more powerful electronics, from revolutionary medical treatments to more sustainable manufacturing processes, quantum fractal alloys hold the key to a brighter and more sustainable future. As we delve deeper into the intricacies of these remarkable materials, we are only beginning to scratch the surface of their true potential. The journey ahead is full of exciting possibilities and challenges, and the discoveries we make along the way will undoubtedly shape the course of human history for generations to come.